Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Solarflare. We have Russell Stern. He is the CEO and president of the company. So, Russell, welcome to the show today.
Hi, Rich. How are you today?
I am doing great. I'm glad it's Friday, but I'm glad we could catch up. We just got out of supercomputing here and heading into the holidays, but I thought we could learn more about Solarflare.
Absolutely.
Well, hey, Russell, I brought your slides up. Why don't we start there and we'll do a Q&A at the end.
You bet. Going right to slide 2, introducing Solarflare, we'll talk about a couple of key points about the company and what we're into. Solarflare makes server networking technology that focuses on a couple of things that are very critical. One, making sure that we can accelerate applications, and we try to do that making it as easy as possible for the customer to adopt our technology. Recently, and I'll talk later about it in some of the other slides, we've introduced a platform for customized compute where both other third-party companies can build purpose-built servers or build their own application, customers that can build their own applications on the product directly hooked with the network. So we have a whole host of high-performance software and hardware for servers. Our applications are mission-critical. We've garnered most of our market in the securities and trading business. We have collectively over 700 customers, and over 600 of those are in the financial services market alone. We've got critical implementations in high-performance computing, storage, cloud implementations, Web 2.0, and also some digital media stuff as well. And so we're traditional two-tiered distribution through companies like Synnex and Ingram Microtech Data in the U.S., a number of companies throughout the world. We partner with a lot of folks in the market in order to be able to jointly meet up at customers and offer solutions, companies like Arista, Cisco, Couchbase, IBM, Fusion.io, Intel, so forth. And all of our products are actually carried by the system OEMs as well, through IBM, HP, Dell, and now over 100 VARs worldwide. And talk about our latest innovation. It's called the Application Onload Engine. And think of this as a mashup between network server adapters and an FPGA, an application accelerator. And so what we've done is taken a very high-performance FPGA and put it on the line side of our ultra-low latency 10 gigabit Ethernet adapter. And what that allows us to do is do data processing in real time right inside the network. And so we can post-process things, pre-process them at line speed ahead of the application. And so for applications that are network-centric, which to some extent are all applications for the most part, particularly as we think of scale-out computing in cloud, big data environments, HPC, including the things that the financial services do with our product. These are all tend to be network-centric applications. So what we're able to do is combine our software that runs on the host and communicates with the application with logic that exists in that FPGA in a way where we can put critical path calculations and applications into the FPGA and have them collaborate with maybe slower path or different parts of the application in the host. And so what we've created here is an open platform that greatly simplifies the third-party development and the deployment of these customized network applications. Notice the title of this slide is that AOE enables programmer to focus on the app. And there are two pictures here. one on the left is sort of a typical FPGA solution where somebody develops a board or uses the development board from a vendor, where they take an FPGA, use some of the I/O blocks in there, and try to stick that thing right onto the PCIe bus. And that necessarily means that developer, whether that's an end user customer developing something that's custom for them, or a third-party developer trying to put an app in the marketplace, that configuration necessarily puts a tremendous burden on the developer, because now he's got this FPGA sitting there. He's defined a whole new register set. He's got to develop device drivers for all the different operating systems that he wants to work in. He's got to know how to bring up 10 gig links. He's got to enumerate on the PCIe bus. He's got to develop a whole set of services around system management, power management, and so forth. And that task is extremely difficult. And for us, knowing how to manage 10 gigabit Ethernet links, we've got millions of dollars worth of laboratory equipment in order to be able to do that, and we know how to use it. Whereas a lot of the smaller companies or, let's say, for instance, a financial institution that wants to use a product, this presents a very long development cycle. So if you look over to the right in the Solarflare AOE solution, you notice all of those devices in purple are already developed technology by Solarflare. And whereas that smaller yellow piece is where the customer can put their code in or the third-party developer. And so we're taking away all of that drudgery of building up all of the services, and we provided a very thorough firmware development kit. It's recently received some critical acclaim by some of our customers for being extremely comprehensive and thorough, so that all of those services to be able to talk to the FPGA, move data on the network through the FPGA, either ingress or egress, is all handled for you via sockets calls that you would do straight out of your application. And this means getting to market and implementing is much, much faster. Our go-to-market model on the AOE is sort of has three legs to it. First, are applications that Solarflare intends to put in the marketplace. These are applications that primarily right now in the financial services market that we've learned a lot about, learned how to write as a result of been working with these 600 plus customers over the last several years. We understand those applications. We know they have broad appeal. And so there's a succession of applications that are going to come out of the Solarflare development team in Cambridge, UK. The second go-to-market model is customer-written applications. And for that, we're providing them, as I mentioned, a firmware development kit that allows them to work on building their own applications. In fact, they can take our application and layer on top of that if they want. And a number of customers that might, for instance, want to build an algorithmic engine for trading or some sort of feed handler or a symbol filtering. In the case outside of the financial services, we have customers that are working on building pieces of the Hadoop functionality, the MapR routines, into the FPGA. In other cases, the Memcached routines, storage accelerators, compressors, decompressors, in the video market, transcoding engines. So there's lots of things that can be done in that middle section of going to market. And then the third go-to-market model are third-party applications. There's a number of different companies that either already do FPGA-like technology today, but they're not that good at the hardware. The hardware is maybe costly for them to do, not as full-featured as Solarflare, or they don't actually do hardware at all. They have an application that runs in software, and they'd like to see that application accelerated by running on the AOE. So you've got three different go-to-market models. Now, in order to build up the market for the AOE, what we're doing is building a very extensive partner network, building the ecosystem. And the goal of that is to build that number one, so we're not competing with our partners. So building up that partner network really comes into three different categories: design services, tools and IP, and application software that can run in there. And you'll note a little picture from our website up there. Customers can go to our partner page on our website and find out who the current partners that have signed up to working and developing both IP tools that help them take C code and convert it into Verilog that will run in the FPGA. And we're continuing to build out that partner network on a daily basis, adding something like 1 to 2, 3 partners per month. And there's some great program benefits to that. There's a catalog of AOE applications. So sort of imagine that at some point you get enough of these applications, they'll all be posted on the Solarflare website. Not exactly set up like an app store, but you can sort of think of it like that. Here are all the different applications that you can get access to in order to be able to run on the AOE. They get help with development and test support, as well as joint marketing. And we launched that in September of this year. These are the current partners, both in the area of design services, tools and IP, as well as third-party developers on there. And you can see it turned out to be a pretty robust list already. We're getting a lot of interest in being able to develop that platform. Again, for companies that are doing design tools or IP for this stuff, what they're looking for is they want to get the maximum benefit of their investment in the development. And so they want a platform. They want a platform they know is going to be adopted by customers. It's going to be broadly available in the market. It's widely distributed throughout the world. And that's what the AOE gives those partner members. This is a really exciting new development. What we did at Supercomputing is launch the Solarflare University program. So what this does at a very significant discount provides an AOE with a firmware development kit to go into university programs, either undergrad or graduate or PhD candidates. It's open to the faculty, the researchers, the students, and so forth worldwide. And what that does for them is gets them the ability to develop on a product or a product idea right on a platform that's already widely distributed in the market. You know, one of the things that you certainly notice yourself is that computer science students that just know software with very little investment can find their way and maybe someday turn out to be Facebook or Google or something. But when you're a hardware guy and you know you're an electrical engineer or a computer engineering student and you're learning how to design chips, you might have to work in the market 5 or 10 years before you develop enough credibility to go raise enough venture capital, and it's very expensive and hard to get to market. And so what we have is a vehicle where those students can develop those skills, put them on a product that can immediately generate revenue in the market. And they've got a built-in manufacturing arm, a built-in marketing arm, and a built-in sales arm right in the market. So these guys get the hardware, they get the firmware development kit at a big discount. We've also started a program for innovation awards. For instance, we're giving away $10,000 to the student that can develop the best application for the AOE. We have other incentives for the best white papers and presentation boards and so forth. And so there's, both recognition and cash prizes. They get a connection to our AOE partner network. And then they get a complimentary attendance to our partner network event in venues both in the UK and the US. And we launched that on November 13th. In fact, we launched our first partner in that. Clemson University has a student that's building a security application onto the AOE. So you can sort of imagine in the world of security, there are two organizations in the world that care a lot about security, the financial markets and the defense markets, government markets. And a lot of the security products that you see in the market today are geared around watching the back door, trying to keep the bad guys from coming into the building. However, most of the threats happen from within inside the infrastructure. And so building right into the server adapter firewall, if you will, intrusion protection system, right into the network, right at the endpoint, turns out to be a very interesting application for the AOE, and we've got a student working on that already. And that's basically the end of my presentation, Rich. There's a backup slide in there showing the entire Solarflare portfolio. There are a number of different server adapters in different form factors. There's also a precision time stamping line of products. You've got a picture of the AOE. And then we show the very comprehensive operating system and driver support for basically every type of virtualization and every type of operating system, including Apple, which we've gotten a pretty large take-up since introducing earlier this year in the digital media market. So with that, Rich, I think a good time to have some Q&A.
Well, terrific. Thanks for that, Russell. Why don't we start with this slide? I had a question about your development environment.
Yes.
Do you need the hardware physically plugged into your local machine to write code for this, or have you made it available over the web or through this firmware thing that you described?
You can write code without actually having the hardware, and if you have so part of the tool set includes the FPGA vendor's tool set that allows you to simulate to a certain extent, depending on what your development environment looks like for this. For instance, here at Solarflare, we own a very powerful supercomputer made by Cadence called a Palladium system. That system allows us to actually run the entire design in a simulated environment before you would actually load into to the AOE product. But when you do need to finally, obviously, test the product and make it work, you need an AOE.
Sure. So going back to the beginning, Russell, what is the origin of this idea of processing on a bump in the wire? Did that start with Solarflare, or was it some research prior to that?
Well, I do believe we're the first and only company to do it the way we're doing it. And so, the origin is that as we were, running through the very large customer base that we have in the financial services market, we discovered that each and every one of those customers, every bank, every exchange, all had some sort of FPGA-like project going on in a back room somewhere. And why? Mostly because Moore's Law has run out of gas, right? Intel can't get the processor speed up much more, so what are they doing? They're adding more cores. And now you've got to kind of change. The world has been doing this, have been changing the way you use multi-core processors. So first way that we did that was, now we've got all these cores, let's virtualize and use those cores to manage different different guests in a virtualized environment. And Solarflare's controller technology is specifically designed for that type of environment, where we can assign different flows and connections to different processors and be able to spread that load across. But when you actually need high scalability and application execution acceleration, you get kind of stuck. Some calculations are not parallelizable, if you will. Some are, but then may suffer from the computational speed of a CPU. So they already recognize that with the amount of trading information, electronic trading information going up, they just can't keep up, and they end up having to build out more and more and more tiers of computers to try to get the job done. And that runs their cost very high and often runs into limitation. So they're all trying to get to this capability of executing in a state machine rather than a CPU. So they turned to us and said, hey, can you guys add this technology to your server adapter? And we studied it for about a year and came up with an architecture, went and built it, and introduced it in the first quarter of this year. And it's been received extremely favorably. We have hundreds of these things deployed in customer environments right now. And it provides, so if you take an AOE and you just put it in a system, and it's got its startup image, which is kind of in a pass-through mode, it looks just like a Solarflare, ultra performance server adapter. Runs all our drivers. Can run Apple, can run Linux, can run VMware. It doesn't matter. And so you put this thing in an environment until you turn on that FPGA and do some code. It'll look just like a standard server adapter. So the idea more or less was born out of the requirement for the financial services market. But you need to think about the more broader application of this technology, which is that in the world of cloud computing, you need to be able to provide this kind of functionality more broadly as a service or a platform as a service. So what we've done by virtue of having our highly virtualized server adapter chip on there is that we can support a virtualized environment using IOV. And so different guests can have access into the application that exists on the FPGA. So now you can not only have this sort of super customized computing platform, but I can have multiple guest access to it in a cloud environment, a private cloud environment. Furthermore, I can configure it and manage it through a software-defined network scheme. So right now, when we talk about soft network control, we're really talking about managing, the switch ports, which device is connected to which ports, which VLANs, which tags, and so forth, which connections do I want bonded and connected to which host. And now I can also assign resources out using a form of software-defined networking for these environments.
So Russell, just from an architectural standpoint, would there be any advantage to making this a bootable device with having that computation on the NIC?
Absolutely. That is a perfectly rational and already conceived use case. In fact, it depends on what the customer wants to do. If the customer wants the application to be entirely run in that network adapter, you can almost think of the server as nothing more than the power supply and management capability, so it can boot up in there and really take over the function that you're trying to achieve. Most of the time, we think it's a better architecture to have some collaboration between the host application and the FPGA, and the reason I say that is because when you try to take a complete application and toss it into that FPGA, you'll necessarily create a lot of complication that might not give you the benefit. And that's why I made that earlier comment. Get the fast pass, get the things that are extremely critical to the performance of your application in the AOE, and do those other parts of it in the host.
Well, great. Well, Russell, kind of a wrap-up question here then. How hard is it to kick the tires on this and see if it's got some wheels for my application?
Pretty easy, right? Just contact any one of our partners, and we've got a lot of information up on our website to take a look at how the product works and what environments it works for. You can contact any one of our partners, and we can get one into customers' hands pretty quickly. And that when they do that and they buy the development kit, that gives them access into our private network so that they can see the API and start to work support on that. They can contact us, and we sort of help them along, give them a little tutorial and so forth. And customers can be up and developing, within, some guys we know, within 48 hours. They order the product, get it in one day, and they're in the lab working with it. You need a computer, an AOE, and an FDK, and away you go.
Well, that's terrific. So it sounds like you're making all the right moves here, Russell. You've developed this technology, and you've done all the hard work, would seem to me, to build that ecosystem, and it seems like it's well on its way.
Absolutely. We're very excited about it. It's a big part of our growth story in the company, and I'm just extremely proud of the customer reception to the product.
Well, terrific. Well, Russell Stern, I want to thank you once again for coming on the show today.
Thank you, Rich. It was a pleasure. Have a great weekend.
You too. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.